Now, let's look at the equations that we were just dealing with. And for the sake of this argument, see, I want to show that these are conic sections. These are ellipses, hyperbolas, parabolas, depending on E. For the sake of this argument, I need A to equal just D times E. Whatever A is, divide it by E, and that's what D is. Notice E, we're never taking it to be 0, so we can divide by that. Anyway. So I'm going to factor an E out at some point, so I want that written this way. Okay. So I want to essentially convert this now into a form that I would recognize as an ellipse, or a parabola, or a hyperbola. So I'm going to multiply both sides by this denominator. I've got r times 1 plus e cosine theta. This is equal to d times e. Distributing the r through, I've got r plus e times r cosine theta equals d times e. And I could have written it that r times e cosine theta, but I wanted to put the r here because I can put it there, first of all, because it doesn't matter what order you multiply three numbers together. You just multiply them. Multiplication is commutative. So I opted to put it here because the r cosine theta is actually x. So what this looks like here is this is r plus e times x equal dE, right? The conversion from polar coordinates to rectangular coordinates, there's the x equals r cos theta. Now bring this over to the other side. R equals dE minus EX, and then factor the E out. R equals D minus X times E, and divide both sides. R divided by D minus X equals E. This right here is what we were talking about in the previous video, where if you got some point xy and you want to look at the relationship between this distance here, which is the radius, and some distance to some line here at x equals d, then the distance there is d minus x. And we're talking that this ratio, r over d minus x, is always equal to this constant e. This is the description of a conic section, right? And in the video where I talked about this, I did the conversion here where you turn the r into a square root of x squared plus y squared, and you actually see the equations of those conics. So this right here is the equation of a conic section, but it's different than the xy ones because this one we know the focus, one of the foci of that conic is at the origin. Because I'm using a cosine curve here, I know that one of the vertices is here on the x-axis. So either I've got an ellipse going this way, or a parabola going this way, or an hyperbola going this way. I know that I've got a vertex on the x-axis and a focus at the origin. Right?